NASA managed to breathe new life into the ancient probe by performing an extremely risky maneuver. Nevertheless, it currently appears that we have only gained a little more time, and that we should slowly start getting used to the idea that even the longest research mission in history will eventually come to an end. Almost 50 years in space has taken its toll. NASA's Voyager 1 and 2 probes have indeed attracted attention from time to time with one or two technical ailments. Just remember the confusing data gibberish that Voyager 1 sent back to Earth from spring 2022 onwards. Although the spacecraft was otherwise functioning as intended, the telemetry data it transmitted simply didn't make sense, and it took NASA scientists several months to uncover the cause of this unwelcome problem. Apparently, Voyager 1's attitude control system had mistakenly tried to route its data through an onboard computer that had long since been shut down. Ultimately, however, the experts were unable to determine the cause of this erroneous data redirection. But more importantly, they were able to use the Deep Space Network radio antennas to get Voyager 1 to send its data to the correct, still intact onboard computer again. However, true to the motto, one complication rarely comes alone, it only took a few months for NASA engineers to face another huge problem. This time, however, it was Voyager 2 that caused the terrestrial experts a headache. An incorrect command had caused the probe's antenna to misalign by 2 degrees and thus point past the Earth. And while the data transmitted to us literally missed us as a result, an interstellar screen was ultimately needed to correct an antenna alignment. The following shows that you also need a lot of patience for such an interstellar screen. Since Voyager 2 was 19.9 billion kilometers away from Earth at the time of the correction command, it took 18.5 hours for the signal to reach it. Consequently, the scientists had to wait just as long for the answer. But after 37 hours, the relieving reaction finally arrived at the Earth-based research stations, and contact with Voyager 2 was reestablished. How NASA engineers performed a technical miracle. But even in the period that followed, the Voyager program staff had no reason to complain about a lack of work. On November 14, 2023, Voyager 1 made headlines again when it was no longer able to properly package and send the unique data from interstellar space to Earth. The cause was a defect in the computer system responsible for packaging the data records into sendable packets. Specifically, the problem was with the Flight Data System, FDS, which collects incoming data from the instruments and other hardware components and converts it into a compact packet of zeros and ones. The data packet is then forwarded to the Telemetry Modulation Unit, TMU, which ultimately transmits the data to Earth. And the bottom line was that it was precisely at the interface between the FDS and TMU that the problem arose. Since communication between the two systems was no longer working properly, the TMU only sent a repeated sequence of meaningless zeros and ones, just like a stuck record. And although NASA experts tried to restart the FDS as early as December 23rd, the rescue attempt was initially ill-fated. The problem could not be solved in this way, and those in charge even said that it would take a miracle for them to get Voyager 1 back on its feet. But as we all know, miracles do happen from time to time. In April of this year, the long-awaited news broke that the ancient probe was at least transmitting again. In the run-up to this, the experts had set about narrowing down the FDS problem more precisely and discovered that the crux of the matter lay in a defective microchip. The corresponding chip, in turn, contained the program code that checked the data processing before transfer. The NASA engineers then toyed with the idea of simply replacing the missing program code and storing it elsewhere in the onboard computer. The problem, however, was the fact that the storage space on Voyager 1's outdated computers is, to put it mildly, limited. But the Voyager team found a creative solution to this. True to the motto, if it doesn't fit, make it fit, the experts developed a plan to break down the affected code into several parts and then store these sections in different parts of the FDS. However, the original program code had to be adapted accordingly, and all references to the original storage location had to be replaced. Furthermore, the experts inserted script lines that showed the onboard computer where to find the next piece of code on its disk, and with a change to the packaging script and the transmission of the new program code snippet, Voyager 1 finally sent back the hoped-for technical data. The following steps were also successful. After several months of hope and trepidation, the probe finally sent scientifically useful data from its research mission again. Of clogged lines and nozzle problems. Aside from all the previous Voyager emergencies, NASA has now also imposed an austerity program on its old probes that is intended to extend the lifespan of their essential systems and important instruments. More specifically, the experts have now deactivated a backup system that absorbs voltage fluctuations and has its own small power reserve for this purpose. The energy supply originally intended for this can now be used for the continued power supply of the scientific instruments. But unfortunately, this NASA conservation measure does not provide a solution for the fossilized fuel lines of Voyager 1. The probe is fundamentally dependent on small positioning thrusters to correctly align its antenna with the Earth. These thrusters, which are fed with liquid hydrazine, correct the antenna alignment in turn with several, only a few milliseconds lasting thrusts. And when Voyager 1 set out into the vast expanse of space on September 5, 1977, it still had 3 of these thruster sets, 1 for course corrections and 2 for attitude control. But with age, more and more aches and pains come, and the deposits that had accumulated in the fuel lines over the decades forced NASA to switch to the second set of positioning nozzles as early as 2002. Unfortunately, however, this too was at risk of becoming clogged at some point, so that in 2018, the switch was made to the third set of nozzles, which was actually intended for course correction. And now, 6 years later, this set is also in rather poor condition. And that is still a cautious assessment. In fact, the course correction nozzles have been affected even more than the 2 position control sets. Expressed in figures, this means that only 0.035 millimeters of the former inner diameter of 0.25 millimeters remain, which is not even half the diameter of a hair. This risky nozzle change saved Voyager 1 again. Since the nozzles were at risk of failing sooner rather than later as a result, NASA decided to revert to one of the 2 previous nozzle sets. However, what seems simple on paper is easier said than done in practice. Voyager 1 has hardly any energy left due to its advanced age, and any power consumption can theoretically result in the failure of an essential system. But without power consumption, it just doesn't work. In order for the deactivated nozzles to be put back into operation at all, they have to be preheated. However, the energy required for this can only be provided if the experts switch off another component. The dilemma here, however, is that all the systems that are still running are actually indispensable. And in the case of the scientific instruments, there is also the risk that they cannot be switched back on later. The deliberations of NASA's engineers were therefore a technical tightrope walk, and after several weeks of deliberations and tests, they concluded that shutting down one of the main heating units posed the least risk. And so it came to pass that on August 27, 2024, it was shut down for an hour while the nozzles preheated during that time. And while those 60 minutes may have felt like a long time to the scientists, not to mention the approximately 22.5 hours that a transmitted message takes for each leg, a collective sigh of relief was ultimately heard. The thruster swap was a success, and Voyager 1 is now able to target Earth again. Well, at least for now. As mentioned, the reactivated thruster set is anything but brand new. It is also already contaminated with deposits that once required its shutdown. And speaking of shutdowns, in the case of Voyager 2, NASA recently deactivated one of the 5 still active science instruments on board. As with the previous cost-cutting measure, this step was also due to the lack of energy, and since the plasma sensor seemed the most dispensable to the experts, its scientific use is now a thing of the past. But does this now also mean that Voyager 2's datasets will have gaping holes in the future? Well, fortunately not. because the corresponding instrument was originally intended primarily for measuring solar wind particles. As a result, it was also pointed towards the sun. However, since Voyager 2 has now entered interstellar space, the direction of the plasma flows has also changed, and the particles are now moving towards the sun instead of away from it. In simple terms, the funnels of the plasma sensor are pointing in the wrong direction, which makes them more or less useless anyway. On the other hand, another instrument of Voyager 2